let's review a few things on scientific notation. So here we have a number in scientific notation, and we're going to change it to standard form, which is your regular everyday number form. And so scientific notation, again, we have this number here between 1 and 10, and it's multiplied by a power of 10 to the third in this case. And so we know how many places we need to move our decimal point based on this number here, our power of 10, our exponent here. And so the exponent is 3, so we'll move the decimal point 3 places. So 1, 2, 3. And it works out that we end where the number ends. So our decimal point will go here, and we'll have an answer of 2,341. And you can think of it as 2,341.0, but in this case, of course, 0.0 isn't necessary. So now let's do another example. So in this case, we have 5.4987 times 10 to the second power, another example of scientific notation. And we're going to go ahead and multiply this out. And so, again, this 2, my exponent, will tell me how many places I moved this decimal point. And so I'll move it 2 places. And notice how it doesn't fall at the end of the number, and that's okay. So we'll have 549.87. So it's not always going to work out to where the decimal point falls at the end of the number. You can multiply a number out and get it in standard form and still have this decimal point here. That is perfectly okay. Let's do another example. In this case, we have 6.11 times 10 to the third. Again, this 3 tells us we need to move the decimal point 3 places. 1, 2, 3. Well, we have this space here, so we need to fill this with a 0. And that gives us 6,110. And again, notice how this didn't work out perfectly. The decimal point didn't just fall at the end of the number after the 1. We had to go in and add a 0. Here we have the problem. Which of the following numbers is written in scientific notation? And so we don't really know what number it is that they're aiming for in standard form when you multiply these out. And it doesn't really matter, but just to show you, let's say you were to multiply all of these out. You'll get the same number each time. So if you multiply this by 10 to the second power, if we have a decimal point here, we move this 2 places over. We would get 415,900. So let's do the same here. You move the decimal point 3 places. 1, 2, 3. Again, 2 zeros to fill in, decimal point at the end. You get the same thing. And so this is the same for all of them. If you go on through, you'll get 415,900. And so whether this is the case or not, even if they were all different, the only thing that matters in order to tell you if this is written in scientific notation is, does it follow our form? So these are all multiplied by the power of 10, a power of 10 of some sort. We have 2, 3, 4, 5, 6 here. But is this first number between 1 and 10? That's what you go by, because you don't know what the number is. It's not saying that it's this exact number, it has to match this. You're going to go by if the number is between 1 and 10. And in this case, D is the only case where that happens. So that's why D is your answer.